Okay, meanwhile, I will introduce myself and my talk. So I'm Matty Kadosh, working as a software architect at Mellanox Technology. And what I'm going to talk about is actually not related directly to Mellanox and Mellanox Silicon. It is more related to SAI emulator, SAI Soft Switch. So we will talk about the motivation, why we need Soft Switch, and how it should look like.
My greatest fear is that I'll type in my password in front of everybody in the room.
I handled that, I didn't do that. Okay. Almost there. Okay, cool. Let's start then. So let's remove that one. Okay, so what you can see in that. Cool. So what we can see in that slide is actually a list of Sonic contributor. It is a partial list, it's not a full list. A few vendors joined recently the community. It looked nice and cool. But if we deep dive into it, we will see a lot of silicon vendor out there, probably the majority of them. We will see good coverage in the system vendor as well. But in the application vendor, protocol vendor, and system management tool, we are missing a lot of contribution. And as a community, we need to add more such vendor in order to make Sonic a really production-worthy open NAS. And this is the intention. And the question is how we can encourage more and more vendor to come to the community and contribute their protocol stack and their application. And here, Soft Switch come into stand. So why we need Soft Switch? Why we need a software-based emulation for Sonic? So the first motivation is for hardware agnostic. So Sonic should be an hardware agnostic NAS. As such, when you write an application, you want the application to work on top of all the hardware and not to be tied to a specific hardware. So how can you write an application that won't be tied to a specific hardware if the only way to write it is on a specific hardware? So one good choice is to have an emulator which is hardware agnostic. And then you will write your application on top of that emulator. And that will ensure you that your application will be an hardware agnostic. And another option is to write it and test it on top of all the hardware vendor, all the hardware platform available. Probably this is not a good idea. Second is debuggability. When you are writing an application, it is much easier to debug a software switch than a hardware platform. In software switch, you have a trace. You can run GDB. You can actually see the packet. You can have advanced log. It is much more easy to debug it that way. It reduces the cost. So if you want to build a complex topology, like the one over here, you don't need to buy a lot of boxes. Though, from my perspective, buying a lot of boxes is OK, but as long as there are Mellanox boxes. But still, we want to enable, as a community, we want to enable users to develop and build a huge topology without the need to buy a lot of hardware. And you can actually develop a feature without any hardware. So you can develop a full-blown feature and put it and push it in without having an hardware box in your lab or in your desk, which actually make it easier for developers to contribute to that community, to the Sonic community. Another motivation, which is more related to maybe to the hardware vendors or to the box supplier, is that today in Sonic community, we do not have a good infrastructure to test the data path. So what we are doing is writing a manual test to verify that a specific feature behaves as we expected. We inject the packet manually, and then we calculate the result, how it should look like, and which port it should come out with, and then we test it. This is the way we test it. The coverage is very poor, and both for features and what we want to do is to increase it. We want to have automated tests, and the idea is that if we have a software switch that emulates silicon, what we can do is actually auto-generate traffic, inject it to the emulator, which will act as a golden model for the other boxes, and then we can compare the result and figure out whether the other box implementation is correct one or there is a bug. So it will help the hardware vendors as well to verify that their implementation, their SAI implementation is the correct one and is confirmed, and make increase the quality of our boxes. So one solution, one simple solution one can thought is actually taking Linux, just a Linux box, which has a router, layer 2 support as well, and give the Linux box to be the emulator, the Linux kernel itself. So though it may be very nice and working for routing protocol, probably most of the layer 2 path will work as well. Moving to more advanced feature like fine-grained ECN and fast reroute and ACL, even ACL. The bare metal tunnel that Dave was talking about will be very hard. So how this soft switch will look like? So back then, when we started in the SAI community, when we started to develop the SAI, so I think it was 2 years ago, 1.5 years ago, something like that, we figured out that it's not enough to define an API. Defining an API is nice, but we need to define the API behavior as well. So we come up with something that calls SAI behavioral model, which actually abstract. It's not a specific hardware architecture, it's more like abstract architecture that define how the SAI switch should behave. And we first describe it in Visio, which was nice, but you cannot run packets in Visio. So then we describe it in P4. So what we have today is a P4 model of SAI. It is not complete model, but we are working on that, or we as a community, not we Mellanox personally. And what we thought, this will be a good infrastructure to put Sonic on top. And this is what we did. So we take that P4 infrastructure, we created a new Sonic platform, Sonic.P4, and then we put the Sonic protocol stack on top. And now what we have actually a Sonic that runs on a SAI behavioral model switch, it's a working pipeline emulator written in software that can run Sonic protocol stack. It is based on Docker. It is actually, there are instructions how to use it, how to download it in the Sonic official wiki page. So what's next? Okay, cool. So what we have there is, we implement the control plan. So we have ability to send and receive packet. You can run BGP, and BGP BDU will arrive to the CPU. Same for other protocol like LACP, spanning tree, other as well. We implement the basic layer 2. We implement basic layer 3, meaning that you can run BGP with the eCMP on top that software switch. But not everything is good. So there are missing features, some essential missing features like ACL and quality of service, and some others. So some other related to the infrastructure itself, like we want to make when you want to add a new feature to that behavioral model, today what we are doing is adding the feature written in P4 and then manually creating a SAI API for that model. What we would like to do is auto-generate those SAI API. In that way, it will be much easier to add more functionality to the model. And we need help. We need help and help from the community. We cannot do it ourselves. We invest a lot of time in that, but we need help. And so I'm asking from the community to help us complete this model. We think that it will actually take Sonic to the next level of maturity. Thank you.
Thanks, Matty. We do have time for one or two quick questions for Matty, then we'll bring up all of our speakers.
Cool.
Quick one. So since Switch.p4 is already available, Switch.p4 is there is already a behavioral model for SAI BM, right?
Sorry, can you say again?
No, the Switch.p4 is already supported as a behavioral model with all the features.
Yeah. So you're asking why not take barefoot Switch.p4 as a model, and the answer is that Switch.p4 is not aligned with the SAI behavioral pipeline.
Okay.
Any other quick questions? We have one here.
Do you have some performance data for this soft switch? So if we run test and we want.
No, we don't have performance data. We didn't reach to that, but we can do that, I guess.
So this is mainly a debugging and bring up tool, not necessarily a deployment, something you deploy in a.
Yeah, of course. It's not optimized. Probably it is not the DBA's efficient way to forward traffic. I guess there are better.
Okay, thank you, Matty.